Hi guys, so if you are watching this on Monday before class even starts, good for you for being an overachiever and learning things before I can go over them in class. If you're watching this at any other time, then still good for you for taking a little bit of extra time to make sure you're prepared for next quiz, test, or just to make sure you know the new material. So today what we're talking about is something a little bit new. We're going to learn what a radian is. So if you think back to geometry, if you remember, before you did trig, all your SOHCAHTOA stuff, your teacher always warned you that you need to change your calculator mode. If you didn't change your mode to degrees, you were going to get all of the answers wrong. Well, we're not going to use a calculator right now, but we're going to talk about what that other function was. And the RAD on your calculator under mode, that stood for radians. So in the past, you guys have always measured things just in degrees, but when you get to a higher level math, you're going to start seeing angles measured also in something called radians. So when I look at an angle, I need to draw that angle. I make sure I'm using the pen. I'm still getting used to this, sorry guys. So when I draw an angle, generally I'll see theta. Theta is a common symbol for degrees. So theta is the number of degrees of that angle. So if this is, 45 degrees, then theta is 45. But when I talk about a radian, what that usually refers to, it's still the same measure of that angle, but as opposed to just being, it's just another way of looking at it. It's kind of the length of that arc. So a radian is a length of the arc. But again, it's still, there are equivalent radian and degree measures. So let's talk about that for a second. Let's say I take a circle. Okay, and let's say I draw that circle on my coordinate plane. That's not really a circle, but we're going to pretend it's a perfect circle. And let's say that radius of that circle is 1. So if the radius of that circle is 1, then you guys know the circumference of that circle is equal to 2 pi r, which means the circumference of that circle, if my radius is 1, the circumference is going to be 2 pi. So what that means is a full circle around is the equivalent of 2 pi. So a full circle in degrees is 360 degrees. So that means that 360 degrees is equivalent to 2 pi radians. Now, something to think about with radians, a lot of people get confused about is a lot of them are going to have a pi in them. But what we have to remember is pi actually is a value. It's 3.14159 and it keeps on going. So even though it's referred to as 2 pi, that's actually 2 times 3.14. So it's actually a value of about 6.28. So it actually is a numerical value. It doesn't have to have a pi in it, but that's frequently your more common measurements that you're going to see. So now that we're looking at things in radians, we can still find coterminal angles, but we're going to find them a little bit of a different way. So let's say, for example, I have an angle of pi over 3 radians. And if I want to find a coterminal angle to pi over 3 radians, when this was in degrees, in order to find a coterminal angle, I needed to add 360 degrees. So in radians, I'm going to be adding the equivalent of 360 degrees, which is 2 pi. So in order to find a coterminal angle, I need to add or subtract 2 pi radians. So with this one, to find my first coterminal angle, I'm going to add 2 pi. Now the only reason that people struggle with radians, it just comes all the way back to fractions. So you guys have to remember what you guys learned about fractions when you were back in elementary school. In order to add fractions, you have to have a common denominator. So my common denominator is going to be 3, so I need to multiply by 3 on the top and 3 on the bottom. And now that I have a common denominator, I can add across the top, so I get 7 pi, and I'm left with just that common denominator of 3. So pi over 3 and 7 pi over 3 are coterminal angles. All right, and again, just like there were with degrees, there are an infinite number of coterminal angles depending on how many times you want to add or subtract 2 pi. So I could find another coterminal angle to pi over 3 simply by subtracting 2 pi. And when I subtract, I need to do the same thing. I need to make sure I get a common denominator. So I multiply by 3 on the top, and I multiply by 3 on the bottom. And then when I subtract, 1 minus 6 gives me a negative 5 pi on the top, and still that same common denominator of 3. So now that I know a little bit about degrees and radians, I can actually convert between the two. So one thing that we learned that 360 degrees was equivalent to 2 pi radians. So if I want to try to figure out how to convert from degrees to radians, I need to figure out what the equivalent, how many radians 1 degree is equivalent to. So I need to take this equation and end up with 1 degree by itself. And one way I can do that is by dividing by 360 on both sides. And when I do that, I'm left with 1 degree is equivalent to 2 pi over 360, which I can reduce to pi over 180. So if 1 degree is equivalent to pi over 180, then in order to convert from degrees to radians, all I need to do is multiply my degrees by pi over 180. So I can take any degree value and multiply it by pi over 180 to get an equivalent radian value. So for example, let's say I want to find 90 degrees in radians. So I would take 90 degrees and I would multiply by pi over 180. And now remember, this is not like when we're adding. This again goes back to fractions. When you multiply fractions, you multiply straight across the top and straight across the bottom, and then you simplify. Or with fractions, you can simplify before you even multiply diagonally. So I know that 90 and 180 are both divisible by 90, so before I even multiply, I can simplify this to 1, and I can simplify this to 2. So 90 degrees, when I multiply, is going to be equivalent to pi over 2. Now I can also do the same thing the other direction. I can take a radian value and I can convert that to a degree value. So I'm going to start this the same way I did last time. I know that we've already previously talked about that 2 pi is equivalent to 360 degrees. But this time, instead of trying to get 1 degree by itself, I want to see what 1 radian is going to be equal to. Not 1 pi radian, but 1 radian on its own. Remember, 2 pi is about 6.28 radians. But if I want just a single radian, not 1 pi, but a single radian, I would divide by 2 pi on both sides. And I can see that 1 radian is equivalent to 180 over pi degrees. Now again, remember, even though this has a pi in it, it doesn't necessarily mean that it's a radian value. 180 divided by pi is actually about 57 degrees. So 1 radian is equivalent to about 57 degrees. But to make an exact answer, because we don't want to round, we want to keep things in terms of pi because as exact as we can possibly be, 180 over pi is going to be what we use to convert from radians to degrees. So what I would do is I would take any radian value and I would multiply that radian value by 180 over pi. Sometimes those pi's are going to cancel out and you'll be left with a whole number. Occasionally, if the original radian value doesn't have a pi, that won't happen. But let's look at an example. Let's say I have pi over 6 and I want to convert pi over 6 to degrees. Then all I would do is I would take pi over 6 and I would multiply by 180 over pi. So in this case, again, I can simplify before I even multiply. The pi's are going to cancel out. 6 and 180 are going to reduce. I'm going to be left with 1 at the bottom, and I'm going to be left with 30 at the top. So when I multiply this across, all I have left is 30 degrees. And again, you can simplify at the end as well, and you'll see those same things are going to cancel out, but I'm going to be left with pi over 6 is equivalent to 30 degrees. Now with radians, there is one last thing that we're going to look at that we're going to spend a lot of time on this year, and that is something called the unit circle. We're going to talk a lot about it in a few different ways, but we're actually going to you'll find that the unit circle notes are actually on a separate video because I need to have a certain picture on there to make it a little bit easier for you guys to see. And right now I'm at Allen High School for a volleyball tournament and have no internet, so I can't get that picture for you. But that second video will show you a little bit about the unit circle, which again is something we're going to talk about a lot this year.